You ever get that feeling, that you're seeing the same shape over and over again? Well, today we're going to crack the code on this one graceful curve that seems to be, well, everywhere. Let's get into it.
No, seriously, once you start to look for it, you can't unsee it. It's almost like a hidden blueprint for how the world works. You find this elegant curve in nature, in sports, even in our biggest, boldest inventions. So, what's the secret? You see it.
Right there, in the perfect arc of a basketball as it just swishes through the net. That beautiful, predictable curve.
And it's not just sports. Look at a satellite dish. That precise curve, same shape. And it has to be perfect to catch those tiny signals from deep, deep space.
And then you see it on a massive scale, that powerful, elegant line of a suspension bridge. It's just hanging there, defying gravity, connecting two whole pieces of land.
So yeah, the everywhere curve. That's what I like to call it, because honestly, once you start looking for it, you really do see it everywhere. It's like this fundamental pattern is woven right into the fabric of our world.
So that brings us back to the big question, right? What is the one single instruction, the one rule that nature and physics and engineers are all using to make this perfect shape over and over again?
Okay, it's time. Let's crack this code. Now, this shape has a name. It's called a parabola. And its blueprint, its secret recipe, is an equation that I guarantee you've seen before, probably back in school.
And there it is. X squared plus bx plus c, the quadratic equation. This is the secret code we've been hunting for. Okay, now don't let the fancy name second-degree polynomial throw you off. All that really means is that the most important part, the key ingredient, is that little x squared right there. Seriously, that one simple operation is what creates the entire magic of this beautiful curve. The best way to think about A, B, and C is like they're knobs on a control panel. You can turn the A dial to make the curve wider or narrower, or even flip it completely upside down. Then you use the B knob to slide the whole thing left to right, and the C knob moves it up or down. It's like a universal recipe. You can make any parabola you could ever imagine just by tweaking those three little values.
And here's the crazy part. This is not some newfangled discovery. No way. The quest to figure this equation out is ancient. We're talking thousands of years old.
I mean, check this out. You've got Babylonian scribes wrestling with these ideas almost 4,000 years ago. Then come the ancient Greeks, guys like Euclid, who tackled it with pure logic and geometry. But the real breakthrough, that came from the Indian mathematician Brahmagupta, way back in the 7th century. He's the one who gave us the first general formula to actually solve it.
So, okay, it's got this long, incredible history. But what makes it so powerful for us today? Well, let's take a look at how this ancient code is, and I mean this literally, building our modern world.
This is where the math just jumps right off the page and into the real world. Think about physics. For physicists, this equation is the language of motion. It perfectly models the flight of a baseball, a cannonball, anything. It's basically the law of gravity written down as math. Then, jump over to a totally different world, business. Here, it's the math of optimization. People use it to find that perfect sweet spot price for something like concert tickets to make the most money possible. And here's the main takeaway from all that. It all boils down to just one equation. 1. That single formula is the key for engineers trying to design those bridges that are both graceful and super strong. It's one of the most fundamental tools we have for describing and, actually shaping the world around us.
All right, now for a pro tip. What if I told you there was a way to know what kind of answer you're going to get before you do all the hard math? Like a little peek inside the code? A mathematical cheat sheet, if you will.
Well, say hello to the discriminant. It's just this small part of the bigger quadratic formula, but don't let its size fool you. This tiny little expression holds a ton of power. It basically acts like a fortune teller for your equation. If you calculate it and get a positive number, you know your parabola is going to cross the x-axis in two different spots. You've got two solutions. If the result is exactly 0, that means the curve just comes down and kisses the axis in one single spot. One solution. And if it's a negative number, well, then the parabola never crosses at all, which means there are no real solutions. It's like having a roadmap to the answer before you even start the journey.
So as we start to wrap this up, I want you to remember something. The quadratic equation. It's so much more than just a bunch of letters and numbers from algebra class. It's a language. And what does it say? Well, you could put it this way. It's the story of a journey up and a journey down. It's the story of anything that rises to a peak
and then graciously returns. That's a story, a narrative, that plays out all around us every single day.
So there you have it. We've cracked the code on one of the most fundamental, most important shapes in the entire universe. And I'll just leave you with this one thought. Now that you know the secret, now that your eyes are open to it, where are you going to see the parabola next?